Heard of trigonometry? Who's heard of trigonometry? Okay. You got some buttons on your calculator, right? What does this one say? Sine. Good. This one? Cosine. And this one? Tangent. Okay. So we're going to be talking about the tangent function today, or the tangent ratio. You guys are running for calculators. Okay, I'm actually going to teach this to you a little bit differently than I've done it in the past, and we'll see how this goes. So let's go back to our 30, 60, 90 triangle for a minute. So we actually memorized some stuff. So here we have a 30, 60, 90 triangle, and we remembered the ratio between the sides. Like we said, if the short leg is 1, or x, or whatever you want to call it, you guys remember how long the hypotenuse was? It was always 2, right? It would be 2, twice as long as the short leg. And then the long leg was always, okay, it was always radical 2 times whatever the short leg is. So in this case, what's 1 times radical 2? It's just radical 2, isn't it? Radical 3, excuse me. Radical 2 is the 45, 45, 90. Okay, so we don't really care about this one today. We're just going to talk about the tangent ratio. So here's the deal. Other 30, 60, 90 triangles can be different size. Like this could be 4 units long, right? And then how long would the long leg in this case be? 4 radical 3. So here's our 30, 60. But you notice here that the ratio between the short leg and the long leg is the same in both of these, isn't it? Okay, so the ratio is 1 to 4, isn't it? Okay, 1 to 4. If I drew a different 30, 60, 90 triangle, well, would it still be similar to this original? Okay, it would be. And so, because every single 30, 60, 90 triangle is similar to every other one, we know that the sides will be in this particular ratio. And what I'm going to show you today is we're going to talk about the tangent of an angle. Okay, and we just abbreviate it like that. So the tangent of this angle right here, 30, is a number. Okay, so the tangent of any angle is just a number. So whenever you see this, you just have to think of that as a single number. And the tangent of 30 degrees is always 1 divided by radical 3. It's always the opposite divided by the adjacent. It's always that particular ratio. And the tangent of 60 degrees, now look at the 60 degree angle right here. Okay, you see the side that is opposite from it? Radical 3 over the side that is adjacent to it, 1. So they're just reciprocals of one another. So if you want to take your calculator out, okay, let's try 1 divided by, now you have to be a little careful about the way you do this, the square root of 3. I want to make sure it does the square root of 3 first before anything. We just get this number, 0.577. And then I want you guys to try tangent of 30 degrees. And what do you see about the tangent of 30 degrees? Okay, it's that ratio. It's the ratio in the triangle of the opposite side, the side opposite from the 30 degree angle, okay, over the side adjacent from the 30-degree angle. It's that number. Okay? So we memorize, in this case, we memorize what that is. Well, we know it's 1 over radical 3. We know what's going on here. What about radical 3 divided by 1? So radical 3 over 1, which would just be radical 3, wouldn't it, is 1.53. And then try the tangent of 60 degrees. Guess what? Now, is anybody coming up with answers that aren't matching? Or is anybody getting anything weird? Okay, bring me your calculator. So there's different ways to measure angles, okay? And a lot of times in mathematics, we like to measure angles using radians, not degrees. It's a little more of an accurate way to do things. But for our purposes, we're going to be using degrees. So your calculator has to be in degrees. Now, if you have one of these small guys, I think it will say DEG on your screen, doesn't it? You guys see that? Yeah, right down here on the bottom it says DEG, which means you're in degrees, which is the normal setting for these. Okay, so with a graphing calculator, the normal setting is radians, and you have to change that. And so I think we can go to mode, and we come right down here, and it says radians. I don't know if you can read that, but that says radians. That's what it's in now. See how it's black? And then degrees. So we just need to go over to degrees and hit enter, so that we are now in degrees. And now when I say, what is the tangent of 60 degrees, it'll give us that 1.73, okay? So that's an important thing. You got to make sure your calculator's in degrees if we're measuring angles in degrees. All right, so with the 30, 60, 90 triangle, we don't need to use the tangent button on our calculator or anything. We know, we memorize the ratios, right? We memorize what's going on. But what about I'm going to back up a minute. Let's say, what if I gave you this triangle right here, and I told you that this was 3, and this was 3 radical 3. Could you guys tell me the measure of angle A? Kimball, what is it?
30.
It's 30 degrees. Isn't it? The only way the short leg can be 3 and the long leg can be 3 radical 3 is if it's a 30, 60, 90 triangle. So the only way this is possible is if I'm looking at angle A, now this is important. If I'm looking at angle A, if the opposite side, okay, divided by the adjacent side, this is the adjacent side, just gives us 1 over radical 3. If we see that ratio, we know that this is 30 degrees. And then, of course, up here, if the opposite side is divided by the adjacent side, so the opposite side divided by the adjacent side just gives us radical 3, then what? That's you should show it more often. Then we know that this angle has to be what? 60 degrees. Okay. Okay. Now we've kind of done this before, but okay, so if you know this one's 30 degrees and this is 10, how long is this side over here? Okay, it's 10 radical 3. You've memorized the relationship. You've memorized the ratio here. Okay? Now, okay, What if it's not 30, 60, 90? What if it's 31, 51, or 59, 90? Now what? Is every single 31, 59, 90 triangle similar to every other triangle that's 31, 59, 90? Is the relationship between the opposite side and the adjacent side to the 31 degrees always the same ratio?
Yes.
It is. And this one's, of course, 59 degrees. And the relationship between the opposite and the adjacent, it's always the same. Do you want to memorize that one? Huh? You do want to memorize that one? What if it's 10, 80, 90? What if it's 189, 90? What if it's 22.57? I don't want to subtract that in my head, 90. I mean, how many different possibilities are there? Yeah, a gazillion. I think that is the number we're looking for. I think actually the number we're looking for is infinitely many, because you could round them off differently. These two angles could be as long as they add up to 90, and there's lots of numbers that add up to 90. So here's the thing. We can use the tangent function. So anyway, somebody has figured this out. This ratio is known. Okay? We know what the deal is with it. Okay? So if we look at the tangent of 31 degrees, the tangent of 31 degrees, well, it's 0.6, let's just say it's 0.6 about, okay? It's about 0.6. So if the tangent of 31 degrees is about 0.6, well, the tangent function is defined this way. The tangent of an angle, which I'll just call theta, that's a Greek letter, that's a tangent of some angle, is always the number you get when you divide the opposite side from that angle by the adjacent side. So this is something you need to write in your notes. The tangent of theta, the tangent of an angle, equals the opposite over the adjacent.
Not for any triangle? Or just
That is for all right triangles. So we are talking about right triangles only. What's that? I can't hear you.
There's like a way you can memorize it called SOHCAHTOA.
Okay, so that's where we're talking about the sine and the cosine and the tangent. Today we're just talking about tangent. Okay, so we're going to get there though. Okay, so here's the thing. If the tangent of an angle always equals the opposite over the adjacent, then the tangent of 31 degrees is equal to the side opposite from it. Which side is opposite from the 31 degrees? 12. Divided by the side adjacent to it, which is x. Okay? This is an equation we can solve and we can find x. Now remember, the tangent of 31 is just a number, right? Okay, it's just a number. It's that number. It's an possibly irrational number, but we can still round it off. Say it's about that number. So here's the thing. I'm going to solve this for x. So I'm going to times both sides of this equation by x. What's going to happen right here? Okay, they're going to cancel out. Then I'm going to divide both sides of this equation by the tangent of 31 degrees. Now remember, the tangent of 31 degrees is just a number. Okay, I don't want to do the tangent of 31 degrees and round it off and then use it later. Okay, I don't want to do that. So what I'm going to do is I'm going to divide both sides by the tangent of 31. Whatever that number is, it's going to cancel right here. And we end up with x equals 12 divided by the tangent of 31 degrees, which is something I can do. I can go 12 divided by the tangent of 31 degrees. My calculator will take the tangent of 31 degrees. It'll tell me what that is, 0.60008 whatever, out to 9 decimals, and it'll divide 12 by it, and it'll give me a number. 19.97. I'm going to round it off usually to 2 decimals. So this is 19.97. So that's how long this one is. Okay. Same problem. Let's look at the 59-degree angle. Okay? I know that the tangent of the 59-degree angle is equal to, what is it? What is the tangent always equal? Opposite over adjacent. So when you look at this angle, which side is opposite from it? X. And which side is adjacent to it? Do you see how that's backwards from when we look at the 31-degree angle? Okay, so that's going to be the reciprocal. So can I solve this for X? What do I have to do to both sides? Yeah, times by 12. Now I'm going to put 12 here. That's going to cancel. I'm going to put the 12 out front, and this reads 12 times the tangent of 59. And it actually means whatever the tangent of 59 degrees is, multiply that by 12. Okay? So your calculator here, the tangent of 59 degrees is that number, and we're going to multiply that by 12. Okay? Does that look familiar, by the way? It's exactly the same number, isn't it? Good thing. It would be bad if that weren't the same number, wouldn't it? Okay? Now, if I just type in, by the way, if I just type in 12 tangent 59, then my calculator knows whatever the tangent of 59 degrees is first, and then multiply that by 12. And you can hit the in parentheses if you want to, but it's not really necessary. It'll work. Okay? So this is how we use the tangent function. We use it when we have a triangle and we are dealing with the opposite and the adjacent sides. So, okay. One of the easiest problems you're going to be asked about today is it's just going to ask you something, and it's so simple, and it's just hard for you. But it's going to ask you what the tangent of angle A is. Okay? And all you have to do is say the tangent of angle A is the opposite divided by the adjacent side. It's 12 over 10 over 12. That's it. And I think it says, and then give it as a decimal. So you would figure out what 10 divided by 12 is as a decimal. Probably round it off. Well, we could say 8.3 repeating, and so we could also say that that's 0.83 repeating. Now, it's funny, this is kind of a holdover from the old days. In the old days, if I wanted to do this problem, okay, and I wanted to know what the tangent of an angle is or something, or this, I would get in my book and I would turn to the back of the book, and there would be about 20 pages of tables, of trig tables. And I would find tangent, and I would go down the tangent column until I got to 0.83, and then it would tell me what angle it matched up with. Now, we don't do that anymore. Why not? Right, okay. But I'm going to give you some of those tangent tables just so you can see how they relate to one another. But when it says, what is the tangent of angle A, give it as a fraction and as a decimal. That's what it's talking about. What is the tangent of angle C? Okay, 12 divided by 10, which is 6/5, which is 1.2, something like that, isn't it? Okay. So that's all it's asking about. Now, if I had my trig table, I could go to the tangent, I could go down the table, I could tell it said 1.2, and I could go over and it would tell me what angle C is. It would tell me what the measure of that angle is. Okay? For you guys today, we're not going to be looking for angles. We are just going to be finding missing sides today, which is a little bit easier. So I have a right triangle. This only works with a right triangle. I know this angle is 32 degrees, and this is 11, and this is something I'm looking for. And when I look at that triangle right there, first thing I think about is, okay, I got 32, I got the opposite and the adjacent. So what's opposite and adjacent make me think of? Tangent. Okay, makes me think tangent. Doesn't make me think sine or cosine. We'll talk about that later. It makes me think tangent. So I know that the tangent of this angle is equal to the opposite divided by the adjacent. Now can we solve for x? I want you to think about what I just did. Can you all see it? I multiplied both sides by x, so these cancel. I divided both sides by the tangent of 32 degrees, so they cancel. This is what I get. I don't want to take the tangent of 32 and make it a decimal yet or round it off. I want to do it all at once. So I want to get as accurate as a problem as I can. So now once I have this, 11 divided by the tangent of 32, 11 divided by the tangent of 32, calculator knows tangent first, then division, okay? And it's 17.60. So read the instructions. It might ask you for answers to 1 decimal. It might ask for answers to 2 decimals. Okay? Yeah.
So this is kind of random, it's on topic. When I was in elementary school, I started learning.
Wait. Say it louder.
When I was in elementary school in 5th grade, I started learning trigonometry.
Uh-huh.
And I went through with a calculator trying to figure out what tangent would equal a whole number because I could find any. Why is it that only 45?
So the tangent of 45 degrees is 1, isn't it?
Yeah.
Right.
That's the only whole number that
So-
I could find.
So when we look at the trig tables, and I'll give you a sheet with trig tables tomorrow. When we look at the tangent, if we start out really low, let's say the tangent of 0 degrees, okay, 0, and then as we get bigger, so when we get up to the tangent of 45 degrees, then we get up to 1. So the tangent of every angle between 0 and 45 is between 0 and 1. Okay, it's that ratio. And then as we get up more, if you get up to the tangent, let me just show you this. Let's say the tangent of 85, still 11. Okay, so as you go from 45 up toward 90, it gets bigger. The tangent of 86, the tangent of 87 degrees, the tangent of 88 degrees, the tangent of 89 degrees. It's getting big, isn't it? Okay? And then the tangent of 89.5, the tangent of 89.9, 572, the tangent of 89.99999, 5,729,500. So as you get closer to 90 degrees, what happens to the tangent of that angle? It goes infinite. It approaches infinity. And so the closer you get to 90 degrees, the closer the tangent of the angle gets to be to infinity. Now let's think about why that would be. Okay, so here's a triangle with a really small angle in it, like 3 degrees. Okay? So if I'm going to have 3 degrees right there, then thinking about this side over here and this side over here, it's going to be fairly small. The difference between them. If I look at a 45, 45, 90. Isn't the ratio here 1, 1, radical 2? We don't have to care about this. But look at the tangent of 45 degrees. What is it? 1, right? It's the opposite over the adjacent. It's 1 over 1. Here, if I look at a triangle like this, where this side's quite small compared to the ratio here. Opposite side, maybe this is 3. Adjacent side, this could be long. It could be like 30. So the opposite divided by the adjacent in this side, see how that's going to be a very small number? It's going to be a very small number, isn't it? But now look at over here where this one's 87 degrees, where the angle's really a large angle. Okay? Well, now the tangent of 87, now we're looking at 30 is now the opposite, and the adjacent's 3. So see how the tangent gets bigger? Okay, so that relationship changes as the triangle changes. So when you're looking at a small angle, it's a small number over a big number. When you're looking at 45 degrees, it's 1 over 1, and when you go above 45, you're going to get a big number over a smaller number. And then as this number gets smaller, this angle is going to get bigger, and the difference between them is going to get bigger, and you're going to, when you divide, you're going to get a bigger number. So that's why that happens.
Same scenario for equilateral and
Say it louder.
Is it the same for like a equilateral equal angular triangle?
So an equal angular triangle, yeah, see there's a problem because it's not a right triangle, right? And so can we use the tangent function on it? Not the way we're using it here. Okay? So now we could split it. Now we have a 30, 60, 90, don't we? Okay? So we could just look at part of it, and that will be okay. So you're out in the forest. There's a tree. Beautiful tree. You measure, you're 45 feet from it, right here. The angle up to the top of the tree, 59 degrees. Can you find the height of the tree? Do it. Not on the calculator. Write it out, solve the equation, then get out your calculator and do it. So write out the function, then solve it for your variable, then get out your calculator and figure it out to, say, 2 decimals. So when you look at this, right triangle. Let's see, 59 degrees. I'm looking for the opposite. I got the adjacent, so that tells me tangent. I'm going to use tangent. So the tangent of the angle I'm looking at equals the side opposite from it divided by the side adjacent to it. So you should always have that written on your paper. Then you're going to solve the equation for h. So I'm just going to multiply both sides by 45. That cancels. And then at this point, I get out my calculator. And we can just type in 45 times the tangent of 59 degrees. And it turns out to be about 75 feet, really, isn't it? 74.89. I think if I was really looking at the height of that tree, though, I would say, oh, it's 75 feet. What do you think? Yeah, I mean, it doesn't matter if it's 74.89, but so read the instructions and just make sure to give answers that make sense, and if they ask for 1 decimal, give it that way. Okay, so there we go. Here's your assignment. Chapter 9.4.